Alright guys, welcome to day 2 of 2.2.4. So we're going to go over how we can now take these non-functions, these circles and these sine degrees, parabolas, how can we finally transform them. So the transformations that I want to focus on today are only the left-right shifts and the up-down shifts, right? We can do flips and expansions and contractions on these. We're not going to focus on those because those actually give us different shapes. Like if you stretch a circle, it's no longer a circle, stuff like that. And then reflecting a circle really doesn't do a whole lot for us. So we're going to ignore that for the time being. So we're going to take the function which we found last time, right? Y is equal to plus or minus the square root of 25 minus x to the second. Those were the two functions that together made up one circle, right? So we're going to use those and try and use, and since we know how to transform functions, we're going to apply those to that and then see what we can figure out. So to do 134, I'm just going to have you do 135 and 136. These are the kind of process of doing 134, right? So go ahead, pause the video, do 135 and 136, and then come back here and we'll talk about it together. Okay, so what we should have found is, so on 135, we take the x minus h and the plus k on the outside. That's how we got all of these things in the past, right? And they've reordered it where they put the x in front of the 25, but you could have left it as 25 minus x minus h to the second. It's going to give you the exact same thing. I'm not really sure why they changed the format there, but they did. So if we change this h and this k, that'll move us, the h will move left, right, the k will move up and down. So what did you find happened to the actual circle when you changed those two parts on your graph? Well, let's check it out. Right? If we did y is equal to square root of I'll do 25 minus x minus h plus k, add sliders for those ones, and then I'll make another graph of the same thing. I think I forgot my square, didn't I? There we go. That looks better. Okay, and then one of them is negative. Okay, so here's my graph here. So if I make these both 0, right, that's the circle that I had the last time, right? But now if I change my k to like 2, right, what did that do to my circle? Moved it all up 2, right? And if I move this h to being like negative, let's do negative 3, right? Then I'm over here. So what happened? Where is this negative 3, positive 2 point? What's special that's the center of my circle. So we call that the locator point for the circle. It's that point which you can use to do shifts from, because it's really easy kind of go to reference point for the entire shape. So that's what's actually happening there. Now, on to number 136, let's take a look back at x squared plus y squared equals 25. So we already really have a graph of that. Right, this is a graph of that. If I make these both 0 again. Right. How does that 25 relate to the actual graph? Well, this is the graph with 25. Well, what if I just change that to x to the second plus y to the second equals, how about 16? How about 9? How about 4? How about 1? How about 36? Okay, hopefully you're seeing that pattern. I picked out some very precise numbers that are special for a reason there, right? What you should notice is that the radius of my circle is the square root of whatever value I have here, right? So this 25 gave me a radius of 5. 36, it's 6. If I make it 16, it's 4, right? So that is determining the radius of my circle, which is probably the other most important part. Because if I know the center and the radius, I know everything about that circle which I could ever care about. So let's hop back over here. And then what would the equation of a circle that has a center at 5, 7 with a radius of 10 be? Well, that would, well, my h would be 5, my k would be -7, my radius is 10. So if I go back over to this, right? Let's think about how can I not keep on using these, right? Because I could say, well, h is, what did it need to be again? It needed to be 5, -7. Okay. So h is 5, k is -7, and then for raise of 10, I would just change this 25 to 100, right? But I really don't want to keep doing this for these two separate functions, right? I want to do it for something like this. So how would this one look? Well, I'm going to take those off and say, well, this minus h, right? That's always on the x. So if I put this x in parentheses, and put my minus h there. If I put my y in parentheses, or sorry, I'm not quite there yet. Spoilers. Right? To get this k away from this square root so that I can square both sides and get back here, I would want to subtract it over and have y minus k. So I'm actually going to put y minus k in parentheses there. Right? And then this 16 is really going to be, I'm going to call it r squared, because it's my radius to the second power. So now all of these sliders do whatever I need, right? If I want my radius to be 10, I have a radius of 10, moved right 5 and down 7, and there's my graph, right? And it said, hey, what if it's 12? Put a 12 there, right? And then voila, now there's my graph. So what would that look like? Well, this would be x minus 5 to the second power plus y plus 7, because minus a and a negative, squared equals 12 squared is 144. Right? So that would be what the equation of the circle that I look for typically is, and that's what you're going to see for a circle almost every single time. You'll see an h and a k, which are going to tell you how it's going to shift, and then that value on the end, if you square root it, that'll tell you what your radius is. So let's finally hop back over here, and then we're going over part C really. So on D, given the equation this, how can you find the radius of the circle? Well, this is going to be a circle that is centered at x is 3, y is -7, and it's going to have a 13 radius, because 13 squared is 169. So there we go. There's our radius. All right. So where's my cursor? There it is. Let's talk about arc closure real quickly. So in both of these families, right, in the function form and in the non-function circle form, h and k told us where that center point was, right? H and k are so important for most of graphing because it tells you where that locator point is, right? On a parabola, it tells you where the vertex goes. On a circle, it tells you where the center goes. On almost every single graph, H and K tell you where the important kind of point where you start your graph from goes. So that's why H and K are so important for us, and luckily it applies to basically anything we ever want to graph. All right, with that, here is our assignment for day 2 of 224. We're doing 146 through 152, and I will talk to you guys next time.